Okay, let's try to differentiate this, but before we do that, let's try to simplify or manipulate this equation first so that it is easier for us to differentiate. So on the right hand side here, I am going to re-express this as ln e to the power of square root of x, then minus ln, then cosine cube x, which is this, and this is going to be square root of x ln e, which is going to be 1, then minus cube, I can bring it forward, so it's going to be 3 ln cosine x. And now I'm going to start differentiating. Okay, it is going to be way easier to differentiate this instead of differentiating this. So for this, it is going to be half, then x to the power of minus half, minus 3, this is going to be 1 over cosine x. Differentiating cosine x is minus sine x. So our answer is going to be 1 over 2 square root of x minus become plus. Then 3 times of sine over cosine, this is going to be tangent. So 3 times of tangent x. This is going to be for part 1. Let's take a look at this. In order for us to find dy dx for this, we must first recognize that we have not learned any results that will help us to directly differentiate a variable to the power of a variable. So we need to do a manipulation. Not like this, this is an optional thing that we are trying to do from here to here, because we can also differentiate this, it's just very tedious. Okay, but for this, we have no choice but to manipulate it first. I'm going to ln both sides for this, so it will be ln y to the power of 1 over x is equal to ln x to the power of ln x, which will become 1 over x. Then ln y, this will be ln x multiplied by ln x, which is equal to ln x square. And please take note, we are not supposed to be bringing these two down, okay? This square is going to be the entire ln x square. It is not like this is not the same as ln x square, okay? Where these two, we will be able to bring it forward, okay? So we're going to stick to this. So this is equal to this, and now let's try to do a differentiation with respect to x on both the left and the right hand side. For the left hand side, I'm going to apply the product rule, so 1 over x, differentiating ln y, it will be 1 over y dy dx, then plus 1 over, I'm going to be differentiating this. So let's differentiate 1 over x, which will become a minus 1 over x to the power of 2, then ln y is equal to, differentiating this is going to be 2, then ln x to the power of 1, differentiating ln x via chain rule, it is going to be 1 over x. So for what I have here, let's try to multiply this throughout by xy, which will be giving us a dy dx here, and this is going to be equal to a y over x, then ln y, multiplying xy throughout. This is going to be 2y ln x. And I'm going to bring this over to the right hand side, which will make dy dx now the subject. This is 2y ln x minus y over x ln y. I think this is a good enough version as an answer. But I mean, it depends on you. We can also factorize out y, since it's the common variable on both the terms. This will be 2 ln x minus 1 over x, then ln y.